In this video, we're going to be looking at how to calculate horizontal and oblique asymptotes. And so we have quite a few examples that we're going to go through in this video. Before we go through the video, let's put the rules on for doing this. So with a horizontal asymptote, if the degree of the numerator is smaller than the degree of the denominator, you will have a horizontal asymptote, and it'll be the x-axis. But quite frequently, well, all the times on multiple choice exams, the correct answer isn't written as x-axis. It's the equation of the x-axis, y equals 0. If the degree of the numerator and the degree of the denominator are the same, there will be a horizontal asymptote, and it will be the line with equation y equals, and it'll start out as a fraction, and the numerator will have the leading coefficient of your numerator divided by the leading coefficient of the denominator. Now, if you can make any cancellations, you do, because we'll want that in lowest form. So if you had y equals 2/4, it would not be correct to write that. You'd be required to write y equals 1/2. Finally, if the degree of the numerator is larger than the degree of the denominator, then there's no horizontal asymptote. Now, with oblique asymptotes or slant asymptotes, if the degree of the numerator is 1 more than the degree of the denominator, so the degree of the numerator is bigger, but it's only 1 more than the degree of the denominator, there will be an oblique asymptote. That is the only case where you have an oblique asymptote. So if it's anything different to this, there will not be an oblique asymptote. Now, what's the equation of the oblique asymptote or the slant asymptote? It will be a line, so it's going to be y equals, and it will be the quotient from doing polynomial division. Now, from these rules, it should be obvious a function cannot have a horizontal and oblique asymptote at the same time, because each of these cases is exclusive, and so you can't be in more than one case at the same time. Okay, so some of these are really easy, others take more work to see. All right, so let's start with this one. We can see the degree of the numerator is 2. The degree of the denominator is 3. So the degree of the numerator here is smaller than the degree of the denominator. And so by this, the x-axis is the horizontal asymptote. And so we will write y equals 0. Okay, it will not have an oblique asymptote because it doesn't fit this case. Also, this video is only looking at horizontal and oblique. We're not considering vertical asymptotes. All right, what about this one? Well, the degree of the numerator is 4, and the degree of the denominator is 4. And so we're in this case if the degree of the numerator equals the degree of the denominator. So we will have a horizontal asymptote, and it's going to be the line y equals the leading coefficient of the numerator. That's the number multiplied by the highest power of x, divided by the leading coefficient of the denominator. Okay. And we want it in lowest form, and negative 16 divided by 8 is negative 2. So my horizontal asymptote is the horizontal line with this equation, y equals negative 2. That's what you'd have to do to write. Okay, well, what about this one? Well, this one is in factored form. These are not. These are in standard form. So you're going to need to get the leading term. What's the leading term? Well, you could FOIL the entire thing out, but why do that if you only need the leading term? I just need to multiply leading term of this one by leading term of that one. So 2x times 3x is 6x squared. And then I'll have other terms, but they'll be x terms or a constant. So the leading term is going to be 6x squared. What about the leading term in the denominator? It's going to be 5x times 6x, which will be 30x squared. And then I'll have other terms, but it doesn't matter what they are. I just need the leading term. So we can see that the degree of the denominator is the same. Degree of numerator in the degree of the denominator the same. So we're in this case. And so I do have a horizontal asymptote. And it's the equation y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. But in lowest form, that's going to be 1/5. So I do have a horizontal asymptote. For that one, it's y equals 1/5. All right, now what about this guy? Well, the degree of the numerator is 2. The degree of the denominator is 1. So we're not going to have a horizontal asymptote. Now here, the degree of the numerator is 2, and the degree of the denominator is 1. So the degree of the numerator is 1 more than the degree of the denominator. So we will have an oblique asymptote. And the equation we get is y equals the quotient when we do polynomial division. Now I can do long division, but also I can do synthetic division, which is quicker with this one. So if it's in the form of x minus a number, I can do synthetic division. So it's x minus the number in the box. And then over here I'll have the coefficient for 3, the coefficient for x squared, the coefficient for x, and the constant. 3 times the number in the box is 3, and then we add. 3 times the number in the box is 3, and then we add. That's my remainder. And these give me the quotient. So here where the line is, that's my constant, and that will be my x term. So I will have an oblique asymptote, and its equation is y equals the quotient. Let's have a look at that one on the graphing calculator. Okay, let's just look at 3x squared in the numerator divided by x minus 1 in the denominator. And then on the next line, let's look at 3x plus 3. And let's start with a zoom 6. And there's our line. So I'm going to probably need to refine this window. Let's see if that gives a better picture of what's going on. Here's my rational function, and there's my oblique asymptote. So again, I think I can refine this better. Here's my rational function, and then here comes my oblique asymptote. So we can see how that fits. Okay. What about this one? Well, again, the degree of the numerator is 1 more than the degree of the denominator. I will have a slant asymptote. And again, I can use synthetic division because this is x minus a number if I rewrite it as x minus -1. Okay, so it's x minus the number in the box. So 2 times the number in the box, then I add. -1 times the number in the box, and then we add. So that's my remainder. And that's going to be my quotient. That will be my constant, and that will be my x coefficient. So my oblique asymptote is going to be y equals 2x minus 1. And again, if I wanted to check that, I can look at it in the graphing calculator. Come back here. And I want 2x squared plus x minus 5 divided by the original x plus 1, but just make sure you put it inside parentheses. And then I said that the oblique asymptote was y equals 2x minus 1. Let's start with a zoom 6 and see where it goes. Okay. And then we have that. So let me make the window a little bit better. After seeing it in the standard, I think I can make this a little bit better. All right, there's the rational function, and there's our oblique asymptote. Okay. All right, what about this one? Well, the numerator, the degree of the numerator is 1 more than the degree of the denominator. There will be an oblique asymptote. Now, I cannot use synthetic division. So I'm going to have to use old-fashioned long polynomial division. Now look at these two. What do I need to multiply 2x squared by to get 6x cubed? Well, I'm going to need to multiply it by 3x. Then you multiply 3x by everything. So 3x by 2x squared is 6x cubed. And 3x times negative 18. So 3 times 18 is going to be 54. So 3x times negative 18 is going to be negative 54x. Then what you do in synthetic division is you subtract that, all of that. And so I'm going to have 6x cubed minus 6x cubed, so that goes away. Then there's no x term here, so it's like 0x plus 54x. And then this comes down here. Now, the degree of this is 1. The degree of that is 2. We're done. You're finished when you get to a degree that's smaller. So this is my remainder. That's my divisor. And this is my quotient. So I do have an oblique asymptote. Its equation is y equals the quotient. And if I want to confirm this in the graphing calculator, I will clear this and I'll put in 6x cubed minus 1 in parentheses divided by, in parentheses, 2x squared minus 18 in parentheses, enter. And then I'll clear this one out, and I'm going to put in 3x there. I'll start with a zoom 6. I might have to refine. Okay, let's see what's happening on this one. Let's see if I can get something a bit better. Okay, I need to see what's happening out at the other side. So you can see in the standard window, it really doesn't show you what's going on. So what's actually happening here is I need to stretch that y window. So here's the rational function. And now there's our slant asymptote. So when we didn't see these bits out here in the standard window, it didn't look at all like it was an oblique asymptote. Okay. All right. What about this one here? Well, the degree of the numerator is 4. The degree of the denominator is 2. There will be no horizontal asymptote, and there's no slant asymptote because this is bigger than the denominator plus 1. So there won't be either. Okay. Let's try one more. Well, we have a constant in the numerator, so the degree is 0. And the degree of the denominator is 1. So there will be a horizontal asymptote, and it will be the x-axis. Okay. Let's look at these. The degree of the numerator is 2. The degree of the numerator is 1. There will be a slant asymptote. But we have to do polynomial division. We cannot do synthetic division. So I look at these two. What do I need to multiply 2x by to get 8x squared? Well, 4x. Then I multiply everything by 4x. And this will give me plus 16x. And then I subtract everything. 8x squared minus 8x squared, they go away. And then I have x minus 16x. And then I've got this -2 coming along for the ride. This has degree 1. This has degree 1. I am not done until you get down to a degree that's smaller. What do I have to multiply 2 by to get -2x by to get -15x? Well, I'll need a negative sign, and I want to get rid of the 2. So 15 halves. That should do it. 2x times -15 halves. Well, the 2's cancel, and I'm left with -15x. And then 4 times -15x, -15 over 2, is going to be -30. And then I subtract. -15x plus 15x, they cancel. And then I have -2 plus 30, and I'll get 28. So that's going to be my remainder. This is my quotient. And so I do have an oblique asymptote, and its equation is y is equal to the quotient. Make sure you write down y is equal to. Don't just write down that, because that's not correct. All right, we need the equation of the line. And again, if you want to check that, you can in your calculator. What about this one? The degree of the numerator is 3. The degree of the denominator is 2. So there will be an oblique asymptote. And we have to do polynomial division. What do I need to multiply x by to get 5x cubed? I need to multiply it by 5x. So now I multiply this by everything. 5x times x squared is 5x cubed. 5x times 3x is 15x squared. And 5x times -x is minus 5x. Then I subtract. And we have to subtract everything. So 5x cubed minus 5x cubed, that goes away. 0x squared minus 15x squared. There's no x term here, so think of it as 0x plus 5x. And then this -8 comes along for the ride. This has degree 2, that has degree 2. We're not done yet because they have the same degree. We're not done until we get to the smaller degree. So what do I have to multiply x squared by to get -15x squared? Well, -15. Now multiply everything here by -15. So I'll get -15x squared. -45x and plus 15. And now I need to subtract that. So everything. -15x squared plus 15x squared, they go away. And then I have 5x plus 45x. And then I have -8 minus 15. And this has degree 1. It's smaller. This has degree 2, so I'm done. This is my remainder. That's my divisor. This is my quotient. And so the equation for my slant asymptote is y is equal to the quotient. And again, we'll check this one, and then that will end the video. Let's do... So let me clear that. We'll have 5x cubed minus 8, close parentheses, divided by x squared plus 3x minus 1, and close parentheses and enter, and clear this second one, and let's put in 5x minus 15. And then I'll start with a zoom 6. Okay, so we can't see much in the standard window. So let me stretch the y. Let's see if that'll give us a better picture. Okay, so I think we might need to stretch the y a bit more, but we're starting to see a better picture here. Let's see if this will give us a better picture. Yeah. Okay, so here's our rational function, and here comes our slant asymptote. Okay. All right, so that ends this video.